For this video, we're going to focus on what a polygon is and the interior and exterior angle sums of a polygon. So first of all, let's talk about what a polygon is. A polygon is a closed figure formed by 3 or more line segments called sides. So what we're going to do is we're going to create a formula that we can use for any polygon to calculate the sum of the interior angle measures of a polygon. So let's first look at a triangle. A triangle has 3 sides, and there is exactly 1 triangle inside of a triangle. We know that all 3 angles of a triangle have to add to 180 degrees. Next, a quadrilateral has 4 sides. If you look at that diagram, it is split into 2 triangles. The sum of 2 interior angles of a triangle would have to add to 360, or 2 times 180 would give me 360. Next, a pentagon that has 5 sides with 3 triangles drawn in. 3 times 180 is going to give me 540. A hexagon has 6 sides with 4 triangles. 4 times 180 is going to give me 720. Now, if you can see the pattern that has been created, we take what's happening, the relationship between the number of sides and the number of triangles is the number of triangles is 2 less than the number of sides. So it doesn't matter what size our polygon is, we can always find the sum of the interior angles using the number of triangles. So a heptagon that has 7 sides, which means it would have 5 triangles. 5 times 180 is going to give me 900. An octagon has 8 sides. That means there's 6 triangles inside with a sum of 1080. A nonagon has 9 sides with 7 triangles for a sum of 1260. And lastly, a decagon has 10 sides with 8 triangles for a sum of 1440. So what we did, we created basically a formula in order to find the interior angle sum. So the sum of the interior angles we're going to represent as S, and we're going to use N to represent the number of sides. So in order to find S, what we did was we took 180 and we multiplied that times our number of sides minus 2. So let's check to make sure that that works for any kind of polygon. So let's look at number 2. Okay, we're looking for the sum of the interior measures of a polygon with 21 sides. Now we don't want to draw that instead of a triangle, so we can use our formula. So our sum is going to equal 180 times 21 minus 2, which is going to give me 180 times 19, which gives us a sum equal to 2,400. And that will work for every single polygon. Now we're going to look at what is called a regular polygon. We're going to take this one step further. A regular polygon is a polygon in which all sides, or all side measures, I should say, are congruent, which means, so therefore, all angle measures are also congruent. Okay, if we need to find the measure of a single interior angle of a regular polygon, what we're going to do is we're going to take our sum, which is S, and we're going to divide by the number of sides. So our formula we can say for that, so if we need to find one interior angle of a regular polygon, what we are going to do is we are going to take 180 times n minus 2, that's our angle sum, and divide it by the number of sides. So let's see what happens. In a regular pentagon, remember a pentagon has 5 sides, so I'm going to say 180 times 5 minus 2 over 5. It's going to give me 180 times 3 divided by 5, which is going to result in 540 over 5, which equals 108 degrees. A regular 18agon. So we have 180 times 18 minus 2 divided by 18. It's going to give me 180 times 16 divided by 18, which gives us 2880 over 18, which gives us a result of 160 degrees per angle. Next, we're going to look at the sum of the exterior angles of a polygon. So remember, exterior angles are going to be supplementary to their adjacent interior angle because they are a linear pair, so they have to add up to 180. So going around this triangle, we have 101 degrees, 140, and 119. If we add all of those up, we get 360 degrees for the sum of the exterior angle measures. For my quadrilateral, if I find all the supplementary angles, such as this, and I add all of them up, I'm also going to get 360. Let's check to make sure that is true for a pentagon and a hexagon as well. So the supplementary angles are 82, 59, 93, 50, and 76. Those also add up to 360. And lastly, let's check the hexagon. We're going to have 51, 56, 68, 57, 63, and 65. Adding all of those up, we still get 360 degrees. So I can make the conclusion that the sum of the exterior angles of any polygon is always 360. So let's take this into a couple questions. We want to know the measure of each exterior angle of a regular hexagon. Hexagon is a 6-sided figure, so if all of our exterior angles have to add to 360 and it's a regular hexagon, that means all of the angles have to be the same. So we're going to divide by 6, and we are going to get 60 degrees as our each individual exterior angle. So let's take this into a different type of question and look at number 9. If the exterior angles of a regular polygon measure 12 degrees, how many sides does the polygon have? So we're going to try to plug it basically into what I did right here, except now I know what my individual angle is. So we have 360 total degrees. I don't know how many sides, that's my x. And we're going to set that equal to 12 because that's how much each exterior angle is according to our problem. We can cross multiply. 12x is equal to 360. Divide by 12, and x is going to equal 30 degrees. Now that is basically what the interior and exterior angle sums are for any polygon. And that's it.